This is Michael King. In this second video on capital budgeting with multiple projects, we're going to look at capital rationing, which is going to be sections 13.4 in Booth, Cleary, and Rakita. Now, companies may often have a table, such as this one, called an investment opportunity schedule, which shows all the different projects that are being looked at, shows their upfront cost, their cash flows in each year, their useful life, the NPV, and they're ranked by either using the Profitability Index or by using IRR. Notice that Profitability Index and IRR give you the same ranking. The problem is that IRR and Profitability Index may be misleading, which is why we're going to focus on NPV to ensure shareholder wealth is maximized. And in fact, we're going to use that equivalent annual NPV to rank from high to low because we've got projects with different useful lives. Here we have 6 different projects. We have the upfront costs ranging from a low of $50,000 to a high of $100,000. We can see that the life of the projects goes from a short project of 3 years to a long project of 7 years. We've got the net present value. Notice that the net present value is positive in 5 out of the 6 projects. And because we have the present value of the cash flows, we can calculate the profitability index, where in project A's case, it is 113,646 divided by the upfront cost of 100,000, which gives us, rounded to 2 decimal points, 1.14. Okay, so we could rank by these profitability indexes to see which projects to choose. If we had no budget constraint, and if these projects were not mutually exclusive or interdependent, then we would simply accept all the positive NPV projects, A, C, D, E, and F. This combination would cost $405,000 and would generate a net present value in total of $46,574. So what if there is a budget constraint of $250,000, meaning we can't accept all the projects? Now we're going to have to look at combinations of only the positive NPV projects that are going to generate the highest amount of NPV, but fit within the budget constraint. And as you can see, A, C, and D has a total net present value of $28,524, and the capital that you would have to outlay would be $240,000. So it fits within the budget. We can do this again for a combination ADE, CEF, ACE, and you'll see that the final combination, ACE, has the highest net present value, but it blows the budget constraint. It goes over $250,000. So it looks like the best project is going to be A, D, and E because it generates the highest NPV but fits within the budget constraint. This is obviously a time-consuming process and one that you can imagine when there's multiple projects, we would have to spend quite a lot of time to find the right combination. Another way to approach this would be to calculate the equivalent annual NPV and rank from top to bottom. Okay, and then look for the combination that has the highest summed equivalent annual NPV that fits the budget constraint. Okay, so here we have the 6 projects again. Notice that now we're using a discount rate, and for simplicity we've just assumed an 8% discount rate for all the projects. And on the basis of that we can calculate the equivalent annual NPV, which is the payment on an annuity with that life that would generate the NPV up front. Project A is going to be the best because even though it's the shortest project life, it generates the most NPV per year. Okay, now choosing between projects C and E, before they had similar NPV, but one was 3 years and one was 5 years, we can see that project C clearly dominates. When we start looking at these rankings, we see that projects A, C, and E appear to be the best. When we look at that combination, however, that blows the capital budget, so we're going to look at combinations that will generate the highest equivalent annual NPV. And you can see that the second best, the one that stays within the budget, is again combination A, C, and D, which is going to generate an equivalent annual NPV of $9,047 per year and a total over the life of all the projects of $28,524. Summary, you have to understand the difference between independent and interdependent projects and how to choose interdependent projects that are mutually exclusive or contingent. You have to use these different tools to evaluate projects, NPV, IRR, Profitability Index, and that EA NPV. You have to understand how to choose projects subject to a budget constraint based on their NPV and equivalent annual NPV, knowing that IRR and profitability index may not give you clear answers. Thank you for your time.